off of you.
Hello everyone! In this short video, we'll be giving a summary on how to answer questions on vectors, specifically find the angles. To start off, how do you find the angle between two vectors? The angle between two vectors can either be an acute or obtuse angle. Imagine when there are two vectors A and B, we can calculate the angle between these two vectors by using this formula. You can determine if the angle is acute or obtuse by looking at the dot product of vector A and B. If the dot product is positive, it is an acute angle. If the dot product is negative, it is an obtuse angle. Next, let's look into the angle between two lines. The angle between two lines will always be an acute angle. The vector of line 1 can represent by vector V1 and the vector of line 2 can represent by vector V2. This angle can be calculated by using this following formula. Moving on, let's take a look at the angle between a line and a plane. Similar to the angle between two lines, the angle between a line and a plane should always be an acute angle. As we can see from the diagram, the angle can be obtained by using this formula is the alpha angle. So to find the theta angle, we have to minus alpha by 90 degrees. Before that, the normal vector of the plane should be obtained first in order to use the formula and get the value of alpha angle. Lastly, the angle between two planes. This angle too should always be an acute angle and can be calculated by using this formula. The vector n1 and n2 represent the normal vector of plane 1 and plane 2.
Now, let us apply this knowledge to do this question. Let's look at the question. Given a line L, the parametric equations of the line are given, and two planes which are pi1 and pi2, the Cartesian equations of these planes are also given. A. Find the point of intersection of the line L and the plane pi1. The point of intersection of straight line L with the plane pi1 is obtained by solving the parametric equations of the straight line L and the Cartesian equations of the plane pi1. Step 1. Find the parametric equations of the straight line L. But worry less because the parametric equations of straight line L are given in the question. Step 2. Find the Cartesian equations of the plane pi1. As I said earlier, the Cartesian equation of the plane pi1 is also given in the question. Step 3. Substitute the parametric equations of the straight line L into the Cartesian equation of the plane pi1 and get the value of t. By substituting the parametric equation into the Cartesian equation of the plane pi1, we got the value of t, which is t is equals to -1. Step 4. Substitute the value of t into the parametric equation of the straight line L. After finding the t, we have to substitute it back into the parametric equations to find the point of intersection. Now, we know that the point of intersection of the straight line L and the plane pi1 is -3, 4, -1. B. Find the acute angle between the line L and the plane pi1. So, for the first step, we have to draw a diagram to get a clear picture. The vectors associated to straight line L and the plane pi1 are V and N1 respectively. From the diagram, when the line L and the plane pi1 intersect, theta is the angle between the line and the plane. Notice that sin theta is equals to cos 90 minus theta is also equals to cos alpha. Since acute angle is taken from the angle between the line L and the plane pi1, alpha is equals to up cos vector n1 dot product vector v divided by magnitude of vector n1 and vector v. From the parametric equations of line L, we know that vector v is 2, negative 1, negative 3, and from the Cartesian equation of plane pi1, we know that vector n1 is 3, 2, negative 5. Now, we have to find the dot product of vector v and n1. Next, we also have to find the magnitude of vector v and n1. After finding the dot product and the magnitude, we can now substitute those values into the formula just now. When we substitute, we will get the value of the alpha angle. For the final step, to get the value of theta, we have to subtract the value of alpha angle by 90.